Hi guys, so in today's video we're going to be doing a proof, and basically what I want to prove is if you have some kind of matrix where you have like a bunch of numbers A, B, C on the diagonal, and then all the other entries in your matrix are 0, so like down here is all zeros and up here is all zeros. So we call this a diagonal matrix, and what's interesting about these matrices is the determinant of this matrix is equal to A times B times C times all these other entries times D. So it's just equal to multiplying all these numbers, and you just ignore all the zeros. So we're going to do a proof for that, and we're going to do it by induction. So let's start with our base case, which is the smallest possible diagonal matrix that we can take the determinant of, which is a 2 by 2 matrix. So we're going to consider a 2 by 2 diagonal matrix. That's going to look like this, where we have A and B, which are elements of the reals, and then 0 here and a 0 here. So we can take the determinant of this matrix, and we can compute that immediately, since it's a 2 by 2, and we know it's equal to A times B minus 0 times 0. So again, that is equal to A times B, which satisfies our hypothesis of multiplying the diagonals. Okay, so next let's do the inductive step. Okay, I think I spelled that right. So we're going to consider some diagonal matrix, which is going to look like A, B, C, where all of these are elements of the reals, and then everything else is a 0. Like this. Okay, and basically our assumption, assume that this determinant of this matrix is equal to the product of this diagonal, which is like B times ... times C. And now we want to show that determinant of this whole matrix is equal to A times B times this whole diagonal. Okay, so we can write out a formula for the determinant of this matrix, and we're going to do so by expanding along the first row. So we know that determinant of this matrix is going to be equal to determinant of this equals A times determinant of this times a box plus 0 times determinant of this row, and then you cancel out this row, and then you take all of these rows. 0 times this matrix plus 0 times the matrix where you cancel out the third column, and then you take the first two columns, and then these next two columns, and so on and so forth. But the idea is that all of these entries are just taken like 0 times some matrix. So actually the final formula ends up being A times the determinant of this box right here. And we know by our inductive hypothesis that this is a diagonal matrix where its determinant, this is equal to the product of all these diagonals. So A times B times D. So we see that the determinant of the overall matrix is equal to the product of the diagonal, as we wanted. So that completes the proof. Thanks for watching. Be sure to like, share, and subscribe.